Okay, this is my final revised concept analysis. So the amount of caffeine in milligrams found in an adult system is T hours after consuming a caffeine soda can be modeled by C of T equals 30T e to the power of T, where T is hours and C is the amount of caffeine in milligrams. Why isn't it going? Okay, there we go. So Mr. Mahalo drinks coffee at noon. I want to know what the concentration after 6 hours and what is the rate of decay. So this first part of the question doesn't involve rates of change, but I just included it. So to find the concentration after 6 hours, I'm going to put 6 into the original function because this function is it models the concentration like per the time. So to know the amount at 6 hours, I just put 6 in for t. And because 6 is the change in time from noon to 6 p.m., 6 hours, and I got 0.446 milligrams. And this is also, you can see, modeled by this graph here. So I have this equation, and then C of 6 equals this. So we can see that at 6 hours, there's like 6 is around here, there's 0.446-ish milligrams of coffee or caffeine in Mr. Maho's body. So now moving on, what is the rate of decay, caffeine decaying in Mr. Maho's body at 6 p.m.? So I need to find the derivative because the derivative is the rate of decay. It's like the rate of change, and decay is change. So I have the original equation, and I need to find the derivative to find the rate of decay. So I just use the chain rule. So for this part, it becomes 30t. Oops, sorry. The first part is 30t. The second part is et. The derivative of 30t is just 30. The derivative of e to the negative t is negative e to the negative t. And then simplifying, putting this times this plus this times this in here. And then the final derivative is c of t. It is negative 30e to the power of negative t times t minus 1. So this equation is the rate of decay of caffeine in Mr. Maho's body. And you can also see here. So the green is the derivative. So you can see that whenever the purple equation, which is the original concentration of caffeine in Mr. Maho's body's this function, whenever it is increasing, the green graph is above the x-axis. And whenever it is decreasing, the green graph is below the x-axis. And here, you can see they meet at 0 because eventually there's going to be no caffeine in Mr. Maho's body. So the rate of caffeine is not changing. It has like a 0 rate of change because it's not increasing, it's not decreasing. So they're both going to be constant at 0. Yes, and you can also see that in the maximum, the turning point, this is at 0 because it goes from who's calling me? Oh, my dad. Okay, because when what was I saying? Just give me a moment. Oh yeah. So when it is increasing, it's above the x-axis, and as soon as it hits the turning point, it goes to decreasing, so it's at 0, 0. Okay. So now to find the rate of decay at 6 p.m., I just sub in 6 to the derivative and got negative 0.372 milligrams per hour. And it's decaying because at 6 hours, we'll find out later, like that we've passed the minimum, and I mean the maximum, and so now the rate of coffee in his bloodstream, instead of increasing, it's now decreasing. So that's why it's negative, because it's decaying. And this is just like proving it. At 6 hours, the rate of decay is negative 0.372 milligrams per hour. Okay, so now finding out what the maximum amount of caffeine in Mr. Maho's body is. So to find the maximum amount, we need to look at the critical points. And so the critical points are the zeros in the first derivative, and critical points could also be where it does not exist, but there's no asymptotes in this equation. So it's just zeros. So to do that, we need to make c prime of t equal to 0 to find, because like c prime of t is like basically the y component, so where y is 0, there's no height. We need to find what the x-axis, like where on the x-axis is, what the x value is. So we plug 0 in for c of t, and then solve. So I divided negative 30e to the power of negative t, like 0 over that, and that's just 0. So then what's left is t negative 1 plus 1 plus 1, t equals 1. So therefore 1 hour is a critical point. And then to look at the other critical points, we must look at the start and end points. The start is 0, 0, because we start at 0 time, and Mr. Hood is just drinking the coffee, so there's no caffeine in his body. And because we also can't have negative caffeine and negative time. So you could say this is like technically an asymptote, but like in the actual equation, it does go in the negatives, but in real life, it can't. So the domain is t is greater than 0, or this should be equal to 0. Sorry, there should be a line here. It's greater than or equal to 0. So there is no end point, because time will continue going on and on and on, even though the amount of coffee will eventually be none in his body. Time will not stop. So, unless it's the end of the world, but I doubt that's going to happen when Mr. Mahmoud and I are alive. So, whatever. Actually, even if the end of the world happens, there'll still be time. So, time will never stop, unless something crazy happens, but I'm getting carried away, so I'll just continue with this. So eventually the curve flattens out to 0 in the grams of caffeine in the body. So there's going to be no set point where it is 0, the minimum, because there's infinitely amount of zeros, because there is infinitely amount of time. So we know that at 1 hour the maximum amount of caffeine is present, but how much is present? So we have our derivative here, and we know that 1 hour is the maximum amount, is when the maximum is. So, and this is not the derivative, this is the original equation, the original function of the concentration of caffeine in the body. So we plug 1 in for the hour, and then we find 11.04. So therefore, at 1 hour, the maximum amount of caffeine present in Mr. Mahmoud's body is 11.04 milligrams. And this is the graph to confirm it. So this is the concentration of caffeine in his body, and as you can see, it starts at 0, 0. Don't mind this because there's no negative time, negative caf. It just, when you start drinking 0, that's when time starts, and that's when coffee or caffeine enters the bloodstream. And then it's just increasing until 1 hour, where the maximum concentration is 11.036, and then decreasing, and then around here it gets to 0. And like here and here, I checked for a long time. It's all 0, okay? All 0. Doesn't increase, doesn't decrease. Well, can't decrease below 0 because no negative caf, but it doesn't increase, okay? So that's that. And so therefore the maximum, absolute maximum is this. And that is all. Thanks for watching. I hope I did better this time.